Bum bum. Bum bum. Bum 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 bum. Bum 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 bum. Starting lesson 3.3, annual motion. Baji Daksun, going around in circles. All right, so let's get right into this. So this is based on Earth's revolution, so in other words, our year. And this is talking about how the constellations move westward throughout the year, so different constellations appearing at different points. Again, this is our year, so this is going to be based on Earth's orbit or revolution around the sun. And the sun appears to travel eastward 1 degree every day. Again, the path that the sun appears to travel through the sky is known as the ecliptic. Remember, at least in the winter time, after we get past the winter solstice, we start getting more and more sunlight. So this is what this is referring to. The ecliptic is inclined from the equator about 23.5 degrees. Hey, that's the tilt of the Earth. Who would have thought science would have so much useful information? Alright, so if we look at the horizon, depending on when we look, colors, there you go, June through December, the sun could be more south or more north, but still rising in the east, just more to one direction. This gives the sun a larger path to travel, or shorter path. So if we look at this path, and let's change to let's do green. Look at this. Here we have one path that the sun can travel. Notice that it's very small. Right? It's not going to be in the sky very long, which means you're not going to have a lot of daylight. So that's going to be our winter solstice. Then we come along and we get some more daylight. Probably about equal. So this is our equinox, our vernal equinox, if we go from winter to spring, which means that this next one, we get a whole bunch of daylight. That's right, bunch of daylight. We will call that summer solstice. And just like in the summer, we get lots more daylight. Alright, so if you were in class, we had this neat activity that kind of shows the different spots that the Earth is located and how the sun travels through different spots in the sky. So North Pole wise, if you're at the North Pole at the winter solstice, you would see that there wasn't any sun rising above the horizon. If you were at 40 degrees, you would notice that we just had a little bit going down. And then if you were at the South Pole, it would, South Pole, not set. Just gotta keep circling around. And then if you were at the equator, it's mostly the same. Alright, and I went through these and I did a few of them so that you could see it. It's kind of hard to visually show you here, but it's basically a handheld version of this, where you're moving the sun around and noticing that it changes as different paths throughout the sky. Alright, the reason we have this is because of our tilt, our 23.5 degrees. And what that allows us to do is have different parts of the Earth have more direct or indirect sunlight depending on the season or their location in Earth's orbit. Notice here in the northern hemisphere, where we live, we're getting indirect sunlight. We're tilted away from the sun. So even though technically we're closer in our travels, we are experiencing winter, which is around December 21st, December 22nd. And then as we go through, so January, we go back to March, and we get our vernal equinox. We're kind of right in the middle. half and half. As we continue to go, now we're tilted towards the sun, so we're getting summer, and then back to fall. And the big reason is because of our tilt. And that's why we had the north and the southern hemisphere have opposite seasons. So while we get summer over here, summer, the southern hemisphere gets winter. And while we get, and why that was really bad. It's upside down now. But while we have winter, they have summer. I'll just correct this like that. There we go. It's been a long day. I apologize. Alright. There we go. So we have winter right here, and then they have summer. Silly Mr. Hernandez. He doesn't know what's going on. Ah, capital letters means I'm yelling. Alright. So what causes the Earth to have seasons? That's going to be the tilt of our Earth. And then there's different seasons as we go along. Alright, it's been fun, but I got to go home and eat dinner. Hopefully it's meatloaf. Meatloaf! The meatloaf! Okay.